chemistry students. Welcome to the first day of acids and base notes. For the bell work, I just want you to put it in your notebook. I want you to think about what acids and bases are. And I want you to think about whether all acids dissociate one hydronium ion per molecule, or one H ion. So are all acids created equal? So what makes something an acid? Acids have several properties in common. First of all, they taste sour, like lemons. Secondly, they're corrosive to metals. They contain H plus or H3O, where that extra hydrogen has actually gone to the water. All acids are dissolved in water. They have what's called hydronium ions. They could also contribute a proton. They could be proton donors. That's the Bronsted-Lowry theory. So an example, we have hydrochloric acid and water. We see that this hydrogen dissociates to the water, and you wind up with a chlorine ion and H3O, or hydronium ion, to make the acid. Some examples of some common acids are Coke or Pepsi, citrus juices, aspirin, stomach acid, battery acid, vinegar, and DNA are all acidic. So there's several different types of acid, and they don't all dissociate just one hydronium ion. So monoprotic acids contain only one hydrogen in their formula, and so they only dissociate one hydronium ion. Some examples would be hydrochloric acid or nitric acid. Diprotic acids actually contain two hydronium ions in their formula. And some examples would be sulfuric acid or carbonic acid. Triprotic acids contain three hydrogen ions in their formula. And some examples would be phosphoric acid and boric acid. A strong acid readily dissociates to produce many hydronium ions in water. Some examples of very strong acids would include hydrochloric acid, nitric acid, and sulfuric acid. A weak acid, on the other hand, it only produces a small amount of hydronium ions when in water. So not all the hydronium ions separate out. Vinegar would be an example of a weak acid. Carbonic acid is an example of a weak acid. Lemon juice is another weak acid. So if you were to look at a picture, a microscopic picture of strong acids versus weak acids, you can see in a strong acid all of the hydrogen dissociated, where on a weak acid we still have some that have not dissociated, so we don't have as much hydronium. All right, indicators are how we decide how acidic or basic something is. An indicator is a chemical that's going to change colors when it's placed in an acidic, a basic, or a neutral solution. You've probably used stripped of pH paper, litmus paper. It turns red if it's acidic. Phenolphthalein, it will turn clear in an acid. It's hot pink otherwise. Red cabbage is a natural universal indicator. If you take some red cabbage and blend it up in the blender, it won't smell great, but you can actually use it and make your own acid-base indicator. Just test some things at home. It will turn red in an acid, and it'll turn more blue in a base. Methyl orange will also turn red. Below you can see a situation where their colors are going to turn and how they're going to turn in either acidic or basic solutions. That is all for today.